is measured with respect to this. This only works if this curvature is not very big. So effectively, although it's spherical, we're going to assume that it's flat. So all the equations make an assumption that it's flat. What that's basically claiming is that sine theta equals tangent theta equals theta if theta is in radians. You're going, ugh. All right. Did I prove this for you last semester? That this is basically true if theta is small? Yes. Do you know what this means?
If and only if.
If and only if. So this is true if and only if theta is small. Well, how small is small? As small as you need. Right? So it gets better the smaller it gets. So what am I saying with all of this? Y'all ever used the unit circle before? So here's the circle. Here's the unit circle. And I draw a angle theta. And I'm assuming that the radius of the circle is 1, which is why it's called the unit circle. Okay, so what's the length of this arc? And for any circle of any type, if I know the angle, what's the length of the arc? All right, everybody, have you all seen this equation before? That the arc length equals the radius times the angle if the angle is in radians. Everybody good with that? So, for purposes of what I'm doing then, what is this arc length? So S is what I'm looking for, and it should be r theta, but what's r? 1, because it's a unit circle. So what is that length? It's theta. Are you with me? Kind of, it's that Friday kind of with you, will you please shut up kind of with you? Yeah, all right. So this is the length of theta. Now, I'm going to drop a perpendicular line down like this. So that's just from this point right here, it drops straight down. And my question for you is, what does the length of that line represent?
R sine.
What was sine theta? If this is theta, what is sine theta? By definition, it's, just use language, don't have to type this picture yet. SOHCAHTOA, it's opposite over hypotenuse. But how long is the hypotenuse? So that is sine theta. Right? That little line is sine theta. That's not a happy look, Maria. Does that make sense what I just said though?
No.
All right. So what I'm claiming is that since sine theta equals opposite over hypotenuse, this is a unit circle and this is the hypotenuse, that's just the radius of the circle, and how long is it? By definition. Unit circle, the radius is 1. So if I divide by 1, I just get the length of the opposite side, but this is the opposite side, so that's sine theta. All right? Now, one more fun thing. What's that length? The green line. Can you tell that it's green from where you're sitting? Right? It's the opposite side, but by extending it, the adjacent side has a length of 1 now. Right? Because I made a tangent where that came out, so the adjacent side has a length of 1, and that's the opposite side. So since this side is 1, because it's just the radius again, tangent theta equals the green line over the white line, but the white line is 1.
Yes.
So, right? So tangent theta is equal to opposite over adjacent, but I extended it so the adjacent is 1. What that tells me, guys, first line, sine theta, curved line, theta, green line, tangent theta. Now picture it. The angle collapses, and as it collapses, can you see that all three of those start approaching the same number?
Yes.
As it gets smaller and smaller and smaller, the differences between them disappear. And that's where this comes from. If theta is in radians, these three things will equal if I get to a small enough angle. And now, you don't ever need to know this in order to take the test, but I despise having magic formulas. So by seeing this, you should be able to understand where the equations are going to come from for the stuff that we're going to do later. So, the mirror is there. This is my mirror. And I put the box of chalk here. What happens then, the mirror is where I start, so I measure from the box of chalk to the mirror, and that becomes S. The mirror is going to oblige by making an image, and wherever that image forms, that's going to be S prime. So the distance from the object to the mirror is S, the distance from the mirror to the image is S prime. And it's all going to depend on something we call the focal length. Unlike what a lot of people assume when they hear the word focal length, that has absolutely 0, 0, 0 to being in focus. It's not related to focus at all. Focal length is just a definition for a way to describe a lens. And what it basically does is it says this. If you choose the focal length to be the location of an image when the object is an infinite distance away. So we make the object, let's make it the moon, because that's far enough, all right? So I make the moon an infinite distance away, and I shine it on this mirror, and I say, where do we take an image of the moon? That becomes my focal length. In other words, it's just defined to be the point for which that works. Are you with me? But I said the moon is how far away? Infinite. So that would mean S was infinite, so what does the first term become? All right, so it just means that the focal point is where the image forms if it's infinitely far away, because the math just shows me that. Right? Because if I make that. So what you do is you go to the store and you buy a lens that has a 10 centimeter focal length. It's a property. It has nothing to do with where things are going to be in focus. It's a property of how they ground the lens or the mirror to make it. That's all it is. It's a convenient choice because it makes the math easy.
So how do they know the S prime for infinite situation?
How do they know the S prime for?
When the object is at infinity.
Well, you're in the right class. We actually show you how we get that. But we're not doing it yet. I want to get these terms out there because people struggle with this a lot. Now, here's the thing. There's also then tied to this is one other big idea, and well, two. But they're all very straightforward, but I just want the words to get into your heads. So, we talked about this before. If I go to the movies and I'm watching a movie, there's an image from the movie on the screen. Does light actually go there? Remember we talked about this. Does light actually end up on the screen? Have you never had somebody stand up and block the projector? You go, I can see their shadow. So light must be going to the screen. So when the image on the screen forms, it's a real image because light really went there. And we call that a real image. When the image forms with light actually present at the location of the image, then we say that's real. Have you ever had a movie where they didn't focus it right so the image was not sharp on the screen? That means it was forming someplace other than the screen. So what focusing means is change it until the image forms right on the screen, and then it's nice, sharp, and pretty. All right? So object distance in the case of watching a movie would be what? If the lens of the projector is the lens, what's the object distance? I mean, the image distance is from the projector to the screen. What's the object distance for a movie? This is old technology, guys. I know the problem. I'm going to run out of analogies for all you super smart young people because you go, they use film in movies? I thought it was all digital.
So in school, when we used to have the projectors where they would place their paper on top and then the thing would light up on the thing, how would that work?
Those are the overhead projectors.
Overheads, yeah.
It's a similar kind of thing, is they have to know exactly the distance between the paper and the thing, and then you would adjust up and down to make the image form on the screen. It would be out of focus, yeah. But let me come back to this. Where is the object if you're watching a movie? Maybe it's film, which gives you the answer. It's the distance from the film to the lens of the projector. So the film has light shining through it, making an image on the lens. I mean, it has not an image, but the light is hitting the lens, and the lens focuses it on the screen, which has to be designed for how big your movie house is, and blah, 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 blah. So anyway, so we've got real and virtual images, light really does or does not go where we see the image. We've got objects, images, and focal lengths, all right? And we're going to do a lot more with this next time, but for right now, just go have a week. Did it work out fine, Vanessa? Did you ever get it to give you the right answers? Isn't that funny? So we shine light through the film, and then the film actually makes an image. I mean, not And it doesn't make any, the light goes from that object to the lens, which makes an image on the screen.
Then he sends it.
Come on,
He will teach you
Megan.
how to draw
Why?
ray diagrams to show why this happens. What's that? Yeah, so the object is in the field of the lens, the image is from the lens to the screen. And the focal length is just whatever lens I'm using.
Yeah.
So for a big movie.
Do you want Monday?
Yeah. Yeah, so you're wanting that, right? Jessica? I saw you come in like.